Oh, did I mention we're going to be recording this?
Yay.
Now you know. All right. Let's start with Torah. What'd you guys say? Why? Okay. So, one more time. The volume didn't add up to be what? 320. Okay. So, if you have the same answer, and when I call on you, say, I already have that one. Okay. Dylan, what do you got?
A, because there's no visual that proves that the measurements are for a cube.
Okay. No visual. All right. Ahmad. What do you got?
Because all of this velocity is equal to 20, but
So they all will be except for, so you had the same one as this one. Okay. Darlene, what you got?
I said that C is not correct because it's different yet it is a measure.
Okay, if you guys could be a little bit more polite so I could hear it one more time.
It's a different unit of measure.
Different unit of measure. Okay. So the rest of them were in centimeters and that was in inches. Good. All right, so I'm just going to kind of open up. Do anybody have anything else different from what we have? We got wasn't 320, no visual, different unit of measure. Everybody else had something like that? Exactly like that?
Yeah, totally.
Totally like that? Wow, you guys are all in the same mind tank. Okay. All right. So, here's what we're going to be doing today. You're going to get some supplies. You already have the paper. We are going to be creating a box. Take a look. Okay? You can do this on GeoGebra. You can change the size of the box. So if you take the two red and move it, you can make it a little bit bigger. And then if you just grab one of the sides, you can fold it up. But we're going to be doing it for real. So we're going to be creating open boxes. In order to do that, we're going to be using pieces of paper. You're going to need scissors and rulers. So you are going to go over to the bin and get yourself a couple pairs of scissors and a couple of rulers for your group. Go ahead and do that right now. I want to see what you can do on your own. Okay. I want you to cut 1 inch off of each corner and see if you can figure out how to make an open box using this as kind of as a guide. Okay. So it should look, you're going to need to cut out the 4 corners so it looks like this when it's 4 corners are cut. 1 inch, just 1 off each 4 corners, and then fold up to make yourself an open box. Just give you about 4 minutes. Okay, so everybody, or most of everybody, has cut out 1 inch. What you got for a length? Melanie, did you measure? What you got? And if we round that up, it's going to be 7. Okay, I'm sorry, that's going to be the width. So 6.5 is going to be our width. Our length. Somebody else measure the long way? 9. How about the height? Did you even have to measure that? No, because the height is the length that you cut out. So if this is 1, that's 1. Now the nice thing about GeoGebra, it's kind of like Desmos. How do you find the volume of a box? What's the volume formula? Length times width times height. So now, if I just go back here into my volume, I don't actually have to go to a different app. I don't need to go to Desmos. Just take my 9 times the 6.5 and then times 1, which is, and then just hit enter, and it'll automatically calculate it. Okay? Guess what I want you to do now? I want you to cut out another 1 inch. So take a minute and see if you can figure out how to take out another inch. So when you're working through here, so think of it this way. Your box should get taller, but it's also going to get a little shorter on each end. So 1 inch, 1 more inch from each end. See what you can do. You've cut out a total of how many inches? 2. So if my side length that I cut out is 2, then my height is 2. What is your new length? Because you cut off an inch on both sides, that's 7. And we cut off an inch on both sides here, that's 4. So now it's 4.5, sorry. 7 times 4.5 times 2. Okay? I am not going to ask you to cut out another inch. I think some of you would spontaneously explode. Okay? So let's figure this out. If this is 3, we're cutting off another inch from 2 ends. So now from 7, we're going down to 5. And 4.5 is down to 2.5. And our height is now 3. So let's see what our new volume would be. So 5 times 2.5 times 3. There we go. Sorry. So first it's going up and now it's coming down. So my volume is getting smaller. So now your next task will be, let's make an algebraic expression. Task number 5 in cubic inches, where x is the side length. So x is my side length, but it's also my height. So I want you to take a few minutes. I want you to think about this on your own, okay, and see if you can come up with an algebraic expression where you're creating a generic one. So instead of 9 times 6.5 times 1, and 7 times 4.5 times 2, and 5 times 2.5 times 3, we're going to create an algebraic expression, which is what I have to do at the beginning of class. I can create and interpret a polynomial that models the volume of a box. So this is kind of the crux. This is the most important part. So if you can't get this part right, well, that's okay. We'll show you what to do afterwards. So take a few moments and see if you can come up with an expression. So instead of L times W times H, it should be all in terms of X, one variable. Here is my box. I'm sorry, here's my piece of paper. I am cutting off. I need a pen. Well, I can make it a little. I'm cutting off itty bitty squares off of each end, right? But we're making what's called a generic square. Yuck. That doesn't look nice. And each one is X. So if you need a visual, this might help you out. Remember, we're recording this. You can look at it later. So it's X in both directions. So really, how many X's do I have in both directions? 2. So along my length, I've got 11 minus 2 X's. Along my width, I've got 8.5 minus 2 X's. And my height is just X. And that is the volume of any box that we create from an 8.5 by 11 sheet of paper. Okay? So you're going to type that into task 5, and then take a look at task 6. What do you think we're going to be doing with our task 5 stuff? Well, let me put that there for a second. What do you think you're going to do with your task 5 stuff? What do we do a lot with Cami and Desmos? When we want to put something someplace else. We want the expression put someplace else. Do we want to retype it? Copy and paste. So look at task 6. We're going to create a graph. So this is similar to Desmos. So in your task 5, you've got your, and you can type this any way you want as long as this stuff is in parentheses. So 11 minus 2x, 8.5 minus 2x, and then the x, Control A, Control C. I'm sorry, this one should go down here in task 6, my bad. And then this kind of looks like Desmos. So click on Algebra. Now it looks like Desmos. You got a plus sign. What do you think you want to do here? I copied it. What you're going to see is a graph that's a little out of control. So if you have a touch screen, you're going to pinch to zoom out until you can see the top of the graph. So if you notice in our table, we started out with 58.5, went up to 63, and then what happened? It went down. So somewhere between 1 and 3 should be our maximum. Now, for some reason, GeoGebra likes to use a different word, and does the same thing as Desmos. If you click right on that point, it doesn't call a maximum, it calls it an extremum, which I find slightly hilarious. So, and that's going to be where your maximum is, okay? So at 1.59 inches, how much volume are you going to get out of that box? 66.15 or 66 and 15 hundredths of a cubic inch. Okay. So my task 8 is already answered, about 1.59 inches. And, put the units in there. And now we're going to talk about surface area. So go back and look at your box. And I want you to think about surface area. If you don't remember what surface area is, you have this great tool in front of you. Open up a tab and Google it. Okay, surface area of a box. But think, okay, most boxes have a top and a bottom. This does not have a top, so that's going to affect how you calculate your surface area. All right, so we do not have 5 unique surfaces. How many unique surfaces do we have?
2.
We have 3. We have the bottom. Okay, so the base is my length times my width, but my length was 11 minus 2x. Need my tool. So 11 minus 2x. And what was my width? 8.5 minus 2x. So that's about as complicated as it's going to get. So that's my base, and I only have one of those. Everything else I'm going to have 2. So what's the first number I should put after I do a plus sign? 2. Okay. So I have 2 sides where one of them, so the height's the same every way around. So what should I put next to the 2? X. And then 11 minus 2x for one of them. And then the other one's going to be 2x again, but this time we have one more thing. 8.5 minus 2x. Okay? So, your last task is to figure out another way to write this expression. But we're running out of time, so I'm going to give you a little hint. Ready? Take your paper and open it back up. Okay, so what's the area of the entire paper without the cutouts?
Oh, it's
11 times 8.5. Oopsies.
90.
Oh! Ouch. I cleared the whole thing. Okay, that's okay. I can write fast. 11 minus 2x, 8.5 minus 2x, plus 2x times 11 minus 2x, plus 2x times 8.5 minus 2x. Okay, so one more time. So I got 11 times 8.5 was the whole paper, but I cut out stuff, right? How many cutouts did I do? Were they all the same?
Yeah. Minus 4x.
4x squared. Your last task is to show that this in task 9 is the same as that in task 10. So what are you going to have to do? A whole lot of multiplying.
Yeah.
That's my least favorite phrase. Okay? No, but you're going to have a grade in the very near future where if you don't practice this now, you're not going to remember how to do it later. Okay? So you're going to have to do 4 multiplications for the first 2, 2 multiplications and 2 multiplications. And what you're trying to do is show that this is equal to this. Okay? Notice that some of the multiplications will be the same. So take just a few minutes and see if you can prove that this is equal to that. And that's your last task for today. So you should have got what I got up here. The first 4 terms are from the 2 binomials multiplied. So I get the 93.5 minus 22x minus 17x plus 4x squared. And then I made a little blue-blue. That's why I changed to blue. So that's 22x minus 4x squared. And then the end, 17x minus 4x squared. So look, I got a 22x and a 22x. One's negative, one's positive. I got a negative 17x, and I got a positive 17x. I got a 4x squared, and I got a negative 4x squared. So 93.5 minus 4x squared, which is what I have at the bottom. Okay. So we've done a few things today. Okay. Tomorrow we're going to synthesize this a little bit, talk about it in more detail. But we created the model. What else did we do? We solved all the different expressions. We created volume. And then you actually added your first set of polynomials today. Okay. Make sure you clean up stuff. Everything either goes in the trash or in the recycle. Big paper goes in the recycle. Little cutouts go into the trash.